All right, guys, let's do this problem easy. So I'm just going to go English to algebra. 30, parentheses, increase by p%, 1 plus p out of 100. Then it decreases by, I'm going to say f, and that eventually leads to a 30% reduction in the price. So first of all, notice how the 30 is kind of a red herring. It doesn't really matter. The original price could start at anything, right? Because the 30s are going to cancel out. So that would just put initial numbers. So I mean, pick values for P and R. So I'm going to say P equals 40, R equals 50. Great, and F is the amount sought. So I'm just going to put in the choices. Look, don't get me wrong. This is a great problem to learn from, to do by hand, and I would do that as well. But we're just trying to focus on efficiency here. You know, we just want to get the right answer. That's what the SAT is about. Get the right answer with as minimal effort as possible. Move on to the next one. Rinse and repeat. If you want a harder test, look at the AMC 12. That has some good questions. Okay, so we're done. Choice B. All right, good job. So don't get intimidated by these. These are just go English to algebra, you know. Okay, we have one of these parabola condition problems. So pretty simple. Step 1, f of x equals ax squared plus bx plus c. And then I'm going to say the vertex. So f of -3 is 0. And this is my way of telling Desmos that it's the vertex. So I'll just put opposite b over 2a. Opposite b over 2a is going to be -3, right? Okay, great. Now, I know it's going to go down. Like c has to be right if we think about it. So this is stuck, right? This is not going to change. Now, what's going to change is this is a c at -2. So just think about it. What are the possibilities? It could either be like -2.0001 on one hand, or it could go all the way down like that, right? So once the vertex is fixed, you want to ask yourself, how can I even vary it? So watch, I'm just going to make c equal to -2.00001. Let me do a plus b plus c. So I realize there's going to be a limit of -3.55 in there, 5.6, 3.5 repeating. And then let me just see what happens when I do -9999999. So I basically rephrase the question, hey, what's in between -infinity and -3.5? Right? -infinity and -3.5 would be -9. Okay? Good. We could try to play around with it to figure out what exactly does it have to be -9, but that's not really important, right? So, you can literally, okay, so I know it has to be like -5 point, you get the idea, right, where I'm going with this. So it's going to be like a little bit less than -5, isn't it, right? So that's interesting, right? Okay, cool. So easy problem. Just look at the conditions. All right, glued together. These ones are fun. So we have equilateral triangle. Then we have it like that. Okay, so this is why I always tell students, memorize the formula of an equilateral triangle, s squared root 3 over 4. So it's going to be easy now. I'm going to say s squared root 3 over 4, but I have 2 of them, right? Good. And then I have plus. Now, what are these 3 going to be? That's going to be 55, right? So it's going to be 55, 55, 55, 165 s root 3. 165 s square root 3. Okay? So that is going to be equal to capital X, right? And then I extend it, right? And then it's glued together. So I get this other region here. But it's only going to count this, and then 2 of the top faces. So these stay the same. Let's copy paste that. That's just going to stay the same, right? I should make it bigger here. And that's going to be equal to what? 61 out of 31x, right? So, comma, 61 out of 31x. All right, easy. And now we just have to put the condition s is greater than, let's just try 1, 2, 3. Oh yeah, so this has to be at 330, right? It gets doubled. Sorry, forgot to do that. There we go. So we see the answer is going to be 11, right? Because once I do that, I realize that. So you want to put that restriction in. It does help, okay? So I know the answer is 11, and I'm done, okay? So just 2 simple equations, and you got it, right? So s squared root 3 over 4 is the formula. Okay, good. All right, easy. Let's do this one. We do it algebraically, but I'm just going to do it like this. So f of x equals x minus 2, x plus 5. And then let's say g of x equals 4 units to the right. So f of x minus 4 plus k. You could easily do this algebraically, but I'm just kind of, I'm not really a fan of the slider, but sometimes it does make it easy. So I want g of 4. I want to keep on doing it until I get a 10. So keep on going. You could use the choices, obviously. Now we should use the choices, right? So, I mean, there you go. We're done. So 20. All right. Again, you can easily do that algebraically as well. All right, I want to show you guys a cool method for this one. I call it the derivative method. So we're going to do, this is going to be our f of x, this is going to be our g of x, and then we're going to subtract them to get our h of x. And we're going to use the derivative method. So it's basically saying that when we get it to reduce quadratic, this has to be a 0, and then the derivative at that point is going to be a 0. So watch this, guys. F of x equals 2x squared minus 21x plus 64. G of x equals, so whenever you have a quadratic linear system and it says one solution, this is tailor-made for that. It makes this so easy. You don't even have to do any work. So I'll do that. Watch this, guys. I'm going to do a couple of derivatives. So h of x0, h of x1, comma, h prime of x1, 0, comma, 0. All right, now watch this. I need to get, my answer is 1, isn't it? x1 is 1. Okay, and as you can see, it also meets right there at 1. So just like we talked about, I'm just going to put the choices until I get it, okay? 21 minus k out of 4. Nope, 21 plus k out of 4. Whoops. I'm done. It's 1, okay? So it's a good method. We can see the other ones don't work. So easy methods, okay? So whenever you have a quadratic linear, I recommend you use the derivative method. It's pretty cool, okay? Good job.